Today I am going to solve a problem from computer network and on routing table, that is routing, the problem on routing. Before also I discussed similar problem from routing, but here something is different, some a little bit is different than the previous problem. That's why I'm going to discuss it. Some changed, there is some change before the previous version. So I'm going to discuss this problem particularly. So what we know that in router a table is maintained which is called routing table. Sometimes it is also called forwarding table. And when an incoming packet comes to the router, then from that router there are outgoing lines or outgoing interfaces, but the packet should be forwarded to any one of the interfaces. So how this interface will be chosen? So that is decided by the routing algorithm, and this routing algorithm uses a table which is called routing table or forwarding table, and there will be some entries in this routing table, and it will compare some results with these entries in the router table, and if any entry is matched, then the corresponding interface will be chosen for the incoming packet so that it will be forwarded to that particular output line. So here also I am giving example of a particular forwarding table of a router. Before also I told about what is the information that are kept in routing table, but that was the notation was in classless addressing notation. So here also I am using the classless interdomain routing, but notation is somewhat different. We will use the mask, the concept of mask here. So before going to elaborately discuss about the problem, I am going to write the routing table entries which are given in the problem. Okay. So in routing table, there is one column which is named as subnet number, This is one column in the routing table, and another second column is subnet mask. This is the second column in the routing table, and the last table is interface ID. So these three columns are there in the routing table, and there are some rows. So what are the rows are there that are given here? So subnet number, first row, the subnet number is 200.150.0.0. And for the first row, the second column, the value in the second column is 255.255.0.0, and the interface ID for the first row is 1. Now coming to the second row is given subnet number 200.150.64.0, and the subnet mask is 255.255.224.0, and the interface ID is 2. Third entry in the routing table, that is third row, is subnet number is 200.150.68.0, and the subnet mask is 255.255.255.0, and the interface ID is given 3. So The fourth entry in the routing table, the subnet number is 200.150.68.64 and the subnet mask is 255.255.255.224 and the interface ID is 4. And the last entry is default, written as default, and no subnet mask is provided for the last entry, but the interface ID is 0. Now the question is, a packet has come to this router which is addressed to a destination address 200.150.68.118. So this packet comes to the router where the destination address is given this. Now the question is, the packet will be forwarded to which of the interface ID? There are 0, 1, 2, 3, 4, these many interface ID. So which interface ID this packet will be forwarded to? So before also I discussed similar type of problem, that how by using the routing table, how router takes the decision that incoming packet to be forwarded in which interface. But here the entries in the routing table is somewhat different, but meaning is same. The previous, only the notation is different, but the meaning of previous with the previous problem is same. So we will see that what is the difference here, how they are the old previous and the previous entries in the routing table that we discussed in previous video, how that are similar to this notation. Only the entry is different, but the meaning are same. Maybe different notation, but meaning are same. So first of all, I want to tell something about the subnet mask. Already I have introduced this term mask. Mask is what? Suppose a destination IP address is given. So mask is used to extract the network information from the destination IP. When a packet comes to a router, it first checks. So how it extracts the network address from the destination IP. The subnet mask, we do the bitwise AND operation between the destination address. This is the destination address. So we do bitwise AND operation between the destination address and the corresponding mask. And after AND operation, we will get a result. If that result tells that the network address when we use a particular subnet mask. So if this network address match with this network address in the routing table entry, that is the subnet number, this subnet numbers and the extracted network address from the destination address, the network address, if these two addresses match, that means this packet which is meant for this destination address belongs to this network number. So it will be forwarded to corresponding entry in the interface ID, which is it will be forwarded to interface 1. If it matches, after doing the bitwise, now you see for every network mask is different, because for network to network mask can vary or may be similar also, and also it can vary or may be similar. So for each of the particular network, a different mask is given, and to find out that whether that destination address is matching with this particular net or not, then we have to do the bitwise AND operation between the corresponding mask and the destination address. And after this AND operation, if the result matches with this network number, then we can say that this packet is meant for this destination network, so it will be forwarded to the corresponding interface identifier. So in this way, the routing, using the routing table, the routing algorithm selects the appropriate output line to forward packet. Now, Here is we know the pattern of the mask. The subnet mask is that it is also a 32-bit pattern, and also but the pattern is somewhat different. Thus, there will be some consecutive ones in the leftmost part, and after that all will be consecutive zeros. Why this kind of pattern? So if we do the bitwise AND operation, the portion for which there is the consecutive ones, if we do the AND operation, then any value with that one, we will get that original value, and any value if ANDed with 0, then we get a 0. As a result, bitwise AND operation, we will get a 0. So that actually what happened, the network address for a particular network, there will be a network number, which is the network number. How it is found? It is found by the network ID part of a 32-bit IP address, and the remaining host part will be 0. So that 32 bits comprise the network address for a particular network. For example, what I want to say here, suppose, so we go through the example, then it will be clear. So first of all, what I will do, the destination address I have, but I don't know that this packet is destined for which network. So what I have to do, I have to compare, I have to do the bitwise AND operation with each of the masks. If the after AND operation, if it matches the result of any of this subnet number, then the corresponding interface will be chosen. But if the address after bitwise AND operation, none of the entries match, then we will take by default, then the default path will be chosen, which is interface ID 0. That is the concept. Now the question is that when the destination address is this, then router will forward this packet at which interface. So first of all, we will, and also one thing I also want to tell, if there are more than one matching in an entry, then we will take the longest prefix for which the matching has been occurred. Because long distance, it becomes more specific. Suppose more than one interest matches, then the entries for which the network party's length is more, so it becomes more specific to that particular network. That is the reason why we have chosen the longest match. We have chosen the longest match. Okay. Now here the subnet mask is here. For subnet mask is 255.255.0.0. That means like IP address, it is also 32-bit number written in dotted decimal notation. So this mask is 255.255.0.0. What happens? This is 8-bit. Okay. So if I convert this 255, it's into an 8-bit number, then all of the 8 bits will be 1, binary equivalent. Then next octet, 255, all of the 8 bits are 1. Then the third octet, all of the bits will be zeros. So 8 bits, all of the 8 bits are 0, and for the last octet also the value is 0, so all of the bits are 0, all of the 8 bits are 0. So that is the 32-bit. Now this we will take in with the we will do the AND operation with the destination address. Destination address, the leftmost octet is 200. So what I will do one thing. 200, if we convert it into binary, so it will be 128 maximum power of 2. Then remaining is 72, then 64 maximum power of 2, then it remains 8, then maximum power 8. So what will be the binary equivalent of 200? Now 1, 2, 4, 8, 16, 32, 64, 128. So here if I write this, the binary equivalent of leftmost octet, which is 1, 1, 0, 0, 1, 0, 0, 0. This is equals to 255, that is mass, leftmost octet value of that mass, and the leftmost octet value for this destination address is 200. So binary equivalent has been written. Now we will come to second octet of destination address whose decimal value is 150. So we will convert this 150 into 8-bit binary equivalent. So how to do that? 150. The maximum value of power that can be first put here, which is 128. So the remaining is 22. Now 22, 16 can be maximum power of 2, then 6, then 4, then 2, 2. So what will be the binary equivalent of 150? 1, 2, 4, 8, 16, 32, 64, 120. So if we write the second octet bitwise, so what will be the value? 1, 0, 0, 1, then 0, 1, 1, 0. Okay. Now what will be the binary equivalent for the third octet of destination IP address? Now 68. That means 64 plus 4. So 1, 2, 4, 8, 16, 32, 64, 120. That is the binary equivalent. And the last octet is 118. If we convert it into binary, so how to find out the equivalent, binary equivalent of 118 is the maximum value that can be here. First is 64 because 128 more than 118. So remaining is 4, 5, then 32, then 16 plus 6, that means 4, 2, 2. So what will be the binary equivalent of 118? Now 1, 2, 4, 8, 16, 32, 64, 128. 0, 1, 1, 1, 0, 1, 1, 0. So that is a binary 30-bit pattern. This is the pattern for mask, which is represented here in dotted decimal notation. And this destination address, its 32-bit binary equivalent is given here. Now we will do the bitwise AND operation. So bitwise AND operation, so it is leftmost octet bit. If we do the bitwise AND operation leftmost octet, the value 200 will not change because this, if we do the AND operation, that is bitwise AND operation, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1. That means which is equals to 200. Which is equals to 200. So if 255 is there, and if any value I am doing the bitwise AND operation or 8-bit number, with this 255 we get the number itself. So here I am getting 200. Similarly here it is 255 and this value is 150. So after bitwise AND operation I will get 150. And now this is bitwise AND operation. All of the mask all bit are 0 and this is destination third octet of destination IP, which is 68. So if we do the ANDing with 0, then we will get all 0. Each bit will be 0. So decimal equivalent is 0, and here also 0 is ANDed with this particular number. So we will get the value 0 after bitwise AND operation. So what will be the what the value I am getting here? The value is 200.150.0.0. That means if we do the bitwise AND operation between the destination address 200.150.68.118 with the mask 255.255.0.0, if we convert both of this denotation into binary 32-bit and doing the AND operation, then the result will be 200.150.0.0, this one. Now this is the network address if that has been extracted after doing the AND operation between the destination address and the corresponding mask. Corresponding mask here was 255.255.0.0. So the network address 200.150.0.0, this is the result, and here if I see the entry in the first table is same 200.150.0.0. So after checking, we can say that now this network address matches with this extracted network address. So router will choose the interface ID. So what it will do? Router will choose the corresponding interface ID 1. No, we have to check all of this because there can be more than one matching. So in that case, the longest network part is for which network, that will be chosen. So, okay, there is a right that this destination network matches with this particular entry in the routing table. Next entry in the routing table is 200.150.64.0, and what is the mask? Mask is 255.255.224.0. So I will write this mask. So what is this mask? This mask is 255.255.224.0. Now if we convert it into 32-bit, that 255, I will get the H1s here for second octet, 255 H1s, and the value will not change if we do the AND operation with that destination address. But what will be the value will change for 224. So we have to convert this 224 to its binary equivalent to find out the network address for the second entry in the routing table. So 224, the maximum value that can be here given for 224 is 128. So remaining is 96, so 64 will be there. This is 232, 32. So what will be the binary equivalent of 224? Now 1, 2, 4, 8, 16, 32, 64, 128. So that is the value for 224. So how that then from the destination address, I will do the piecewise masking. So what will happen? The destination address is here, that is here 200.150.68.118, 200, then 150, then 68, then 118. And the mask value here is 255, here is 255, and here 224 means what? 1110, 000, and this is 0. So what if you see, if I ask you in this mask, how many consecutive ones are there? Mask is a particular pattern of 32 bits such that in leftmost there will be some specified number of consecutive ones, and after that all will be consecutive zeros. So if I ask in this mask how many consecutive ones are there, so if you see 255 means there are 8 consecutive ones, then second octet 255 means another 8 consecutive ones, then third octet is 254 where the binary equivalent is 11100000. So here number of consecutive one is 3. So in total, then after that all are 0, and the last octet all are 0. So how many consecutive ones are there? 8 plus 8 plus 3. That means 19 consecutive ones are there. So the network number here it is 19 bits long. Network number, the network, in the 32-bit address there are two parts, network ID and host ID. So here network ID is 19 bits long. So here what I will do, now I will do the bitwise AND operation with this. Now 1, 2, 4, 8, 16, 32, 64, 120. 1, 2, now this. If we do the bitwise AND operation, this becomes 0 and this is 0, 0, 0, 0, 0, 1, 0. So what is it, if you convert it into decimal, what will be 1, 2, 4 is 16, 0, 0, then 1, 0. 1, 2, 4 is 16, 32, 64, so it is 64. So the network address extracted is 200, 150.64.0. So our network address for this particular mask will be, that is extracted from the destination address, is 200.150.64.0. Okay. Now if we check whether this matches with that corresponding entry in the routing table or not. So we have used this mask and the corresponding entry is 200.150.64.0. that is matches with our result. So destination address, if we extract the destination address, the network address also match with this particular network also. But here the mask was 16 bits long, but here the mask is 19 bits long, so we have to take the longer one. So we are now considering this entry only. So this is cross because this is longer than this. Till now the comparison is not over because there are two more entries and we have to check whether they can match with it not. If they match, then who has the longest network ID part, that I have to check. So we will go to, so it was a network where the network ID part was 16 bits and it is the network where network ID part is 19 bits. As we will select the longest prefix, so I will take this one up to now. Then I have to check with this particular destination, particular network number, and the net mask is this. Here you see the network mask is 255.255.255.0. So 255 means first octet all 8 bits are 1, second octet all 8 bits 1, third octet all 8 bits 1. Then remaining is 0. So how many consecutive ones are there? 8 plus 8 plus 8. That means 24 bits. So here the network ID is 24 bits long. Now I have to check if we do this ANDing, bitwise AND operation with the destination address, what is the network address we extract? So what was the destination address? Destination address is this. So I'm writing the destination address now. Writing the destination address, which is 200.150.68.118 and the mask is 255.255.255.0. So if we do this AND operation, for 255 there will be no value change with the original one. So the AND operation result here it will be 200.150.68 and with 0 the result AND operation the value will be 0. So what is the network address I am getting here after AND operation with the destination address and the corresponding mask? We get the network address 200.150.68.0. Now we will compare this with the entry in the routing table. See, we have taken this mask and the corresponding network number is this 200.150.68.0, which matches with the result. Now this destination address also matches with this network number. So which one to take? Here it matches, it was 19 bits. Here it is 24 bits because here it was 19 bit long network ID part. Number of consecutive ones will tell you the network the number of bits in network ID. So here it was 19 bits network ID length, and here the network ID length is 24 bits. as they match with both, but this is the longest prefix, so I will take this one. So this one is cross. So now this is our answer. Still I have to compare with this particular entry. Now here the mass is 255.255.255.224. So what is its binary equivalent? 255 means 8 ones will be there. Then second octet 255, another 8 bits. Third octet 255, another 8 bits. And 224 means only 3 bits will be 1. Because here already we converted, when we converted 224 here, see, these 3 bits were consecutive ones. So for this particular mass, how many bits are consecutive ones bit? Now 8 plus 8 plus 8, 24 plus 3. That means 27 bits there. The network ID part is 27 bits long. And the remaining part is 0. So what we will do? We will do the AND operation with this particular destination address. So how to do that? Here the destination address is this 200.150.16.64. So what is that? What is that? That is 200.150.68.64. And the mass is 255.255.255 and 224. So only this 255, this part I don't have to do anything because the value will be as it is. Only the last octet value will be changing. So 64 means its binary equivalent 1, 2, 4, 8, 16, 32, 64, 128. And the binary equivalent of 224 is 3 ones, then all will be 0. So if we do the bitwise AND operation, 255 is ANDed with 200, we get the 200. Then 255 ANDed with 150, binary bitwise ANDed. Then we get the 150 same. Here 255, 68, I will get 68, but here 64 and 224, if we do the bitwise AND, bitwise I have written here, so it will be 0, 0, 0, 0, then 0, 0, 1, 0, so which is equal to 64. So what is the network address that is extracted here? 200.150. No, here one thing is that the destination address here, it is not 64. The destination address I see here, it is 118. So here I am doing the last octet AND operation once again. It is 118, and the binary equivalent of 118 I find out it before also. It was 0. It was 0, 118, 0, 111, 0, 110, and it was ended with 224, which is this one, then 0, 0, 0, 0, only the last octet I am doing that. So here 0, 0, 0, 0, 0, 110. So what is its decimal equivalent? 1, 2, 4, 8, 16, this is 32, this is 64. So it will be 96. So what will be your network address extracted from this particular destination address and for this particular mask is equal to 200.150.68. They will be as it is because they are all 255, and the last octet is 96. So that is the network address, and if we compare it with the routing table, see, the 200, 150, 68 match, but last value was 96 and here 64. So it does not match with this particular network. So our answer is this. So interface, which interface the packet will be forwarded? The interface tree will be chosen to forward the packet. So that is how the problem is solved. But here before I solved it using prefix, using slash notation, I use to find out the prefix. Here also, suppose for this particular network, this is the network address and this is the mask. Mask means the length of the prefix. Here length of the prefix is 8 plus 8 16. So I can write this network as 200.150.0.0/16. So if this notation and this notation are different but meaning are same. Similarly, this is the network address and the length of the mask is 8 plus 8 plus 3, that is 19 bits. So we can write this network as /19. That means the length of the prefix is leftmost 19 bits. Here the 24 bits are length of the prefix, so I can write this as /24. Here is 27 bits for network, so I can write this as /27. And if the network address does not match with any of those entries in the table, then by default interface 0 was could be chosen in that case. But here it matches with these 3 entries, but among the 3, this is 16 bit long, this is 19 bit, and this is 24 bit prefix. So we will choose the interface longest prefix. So that will be forwarded to interface 3. So that is the concept of subnet mask. That subnet mask is used to expand the network number for the particular destination IP address, the network number. If that network number does not match, then no problem. If matches, then I have to again check whether it is the longest prefix or not. If it is the longest match, then we will select the corresponding interface ID. So here the mask can be, either we can write the entries in the routing table by using this notation like 200.150.0.0/ or we can write the network address and the subnet mask. In this way, we can write the entries. In any way, we can write it. Okay. So, thank you.